Hello, I'm Carl. I'm the team leader of DreamHack Network, and we're about 30 person who builds the network here at DreamHack. And this is my colleague Rock.
Yeah, my name is Rock. I'm Nick Lurg, and I am the group manager of the core part of the network team. Consists of 6 people.
Yeah. So the team that builds the network consists of 30 people, and we have 4 different groups. The groups are the access group, and they build all of the table switches, which are about 400. And those are the ones that you can see down if you sit here at DreamHack. And then we have the core part, and those build or configure the big routers, the ones handling all the traffic. Then we have a service team that runs the servers and things like DNS and so on. And then we have a logistic department consisting of 2 people, because we saw a need for handling all the equipment. The equipment that we have here at DreamHack are Styxel and Cisco based, and there are 400 on the tables, or that you as a participant in this event will see that you will connect to. Then from these we have uplinks towards our core network, and that's where Rock spends most of his time, so yeah. I'll pass it to him.
In the core we have Cisco routers, the 7600 series, and we also use the 3750 series to aggregate all the access switches up to these routers. The core routers are then linked together and have 2 10 gigabit internet links.
Something that's new for this event is that we have built a solution where the distribution part is redundant, and also the core is redundant, so we can lose one of these 2 core routers, or if it reboots or something happens with it, then we'll still have access for all the participants. So besides these core routers, we also have servers, which we have about 15 physical servers that we use to handle our network, or the network need, and things like DNS, DHCP, SMTP, and monitoring of the network. We're running a NOC, which works 3 people, working in 8-hour shifts. So we have coverage for the whole 72 hours that the event is. We have people looking at maps and seeing that if something goes down, we go out and immediately fix the problem. And usually if the power goes out on a section, the guy from the network team is there before the participants have been in and reporting the error in the. So we're quite good at seeing problems with the network. Continuing on that track, we have some additional equipment. We have a packet logic which help us prioritize the gaming traffic, so that the gaming traffic will not be affected by, for example, file transfers or other things, and that will help the latency to stay low. Then we also have some security features in the network. We have firewalls to protect our servers, and there we have a Fortinet, and I'll let Rock, who have been configuring it, tell a bit about that.
Well, security has been one of the most important issues that we have seen the last events, and something that we have seen as something important that we want to explore more. And this event is the first time that we use a Fortinet, a FortiGate firewall, to protect our servers and services. And we use the 3950 series, and it's a clustered firewall in transparent mode. So it's actually not doing any routing with the traffic, but it's just letting the traffic through, but still doing firewalling and also IPS and IDS service.
For the participants' computers, we mostly rely on their own firewalls and their own antivirus software. So we don't have a big firewall that protects the participants. We instead allow that to be on the single computer. What we have is a support team, which is about 20-25 people, which assists the participants if they have problems or if they think they have been attacked. And if they have been attacked, they can later come to us, or the support will come to us, and we will help them finding who is doing it or what could happen and how we can protect them. So here at DreamHack we use about 20 kilometers of cable, TP or twisted pair cable, and that is used to connect the table switches until the core network through a distribution layer. And we have some special things here to build the network as fast as possible. Back maybe 5 years ago or something like that, what we did was we took the table switch and we put it there, and then we took one cable and one cable all the way, so a lot of cables, and this took maybe 1 or 2 days just doing this cabling. What we've done there is we're creating something called vilse-stam, and this is actually a split up. So on the tables we have something called tables or bordsstam in Swedish. So we put that on, and it's a 7 meter, it's a 15 meter and a 25 meter cable just put together by using some tape or something like that. And then at the edge of the table we have connectors which we connect to a core stam. And then it goes into our rack cabinet, and there we have a patch panel, and then we do patch paneling into the actual devices. And this helps us so we can do the same thing that took maybe 1 or 2 days before, takes a few hours now. So that's a really efficient thing to do, and we save a lot of time by doing this. And for fiber we have about 4 kilometers of fiber, I believe. And maybe you can tell a bit about the 10 gigabit interface.
Yeah.
The ER.
The ER interfaces. For fibering, we use both single fibers and fibers that are more pairs, and almost explicitly single mode. We use some multi-modes still, but single modes is what we want to use, because often it's quite far between the routers or the distribution layer, so we want to use single mode. And on the internet links, we are using fiber optics with ER, and that's because Telia, who's providing the internet, is about 13 kilometers from us, so we have to use fiber optic that actually supports these distances.
A few years ago we actually tried to do 10 gigabits per second. Our core network is mostly 10 gigabits, or all 10 gigabits even. Yeah. 20 gigabits between routers. But what we tried to do then was to shoot or use 10 gigabits over multimode. But unfortunately the already existing infrastructure here at Elmia did not support that. As for the single mode, this is something that DreamHack has built together with Elmia over the years, maybe the first one 7 years ago or something like that. So we actually have DreamHack fiber optics at Elmia that we're using to get the high speeds. So here at DreamHack we have about 70 wireless access points. It's similar to what you have at home, the small device with a lot of antennas. But here at DreamHack we use 70 of those, and they are Cisco. So the access point is dumb or stupid. So what it does is it fetches it from a central controller. And then with this controller it pushes the software down to the access point, and then the access point will allow visitors from or at DreamHack to tune in to 4 different SSIDs. And first there is a public network, which you get to a portal, and on this portal you will get the key for this party SSID. And the reason for this is because if we run a public open VLAN without any encryption, anyone could see this traffic. So what we've done is that we publicize the key, and then using VPA2 we do a key exchange, and you get a per session key. So that raises the security a bit. And then we have 2 other SSID, one for the exhibitors, which is a bit QS, so higher QS. So if a lot of wireless traffic is going, they will have a bit of better service. We also have one for our crew, which is about 400 people. So we have about 400 in the summer, and maybe 600 or something like that table switches, and those are a lot of switches to configure manually. So we have written some smart scripts and some smart things to do this faster. So it's began with, we have a device called Sixel 3024. And this device has a binary configuration. So what you need to do is that you need to configure it, and then you need to save it. And it's even worse than that, because this specific device can only be configured through the web interface. If you go through the CLI, you can do the changes, but you can't save them. You save them and then you reboot it and they are gone. So you have to go through the web interface. So we started there by doing a script that logs in and do the configuration, and then it pulls it out with FTP, saves the configuration for every switch that we need to configure, and then we can go manually. We started with putting all the switches on the one table and configuring them one by one. It took maybe 1 or 2 days. But we have evolved from that, and now we put all the switches out, and then we have one global VLAN that all of the switches are in, and they are all on the same IP address. That's 192.168.0.1 or something like that. And what we do is that we have a machine called switch configuration, which sends up ICMP echo request, and then it gets a lot of replies, and then it finds one MAC address, and then it statically locks the ARP towards this MAC address, and then we can configure one of the switches, and then when it's rebooting, we go to the next one, and so on. So we can configure the whole network in maybe 1 hour now, compared to the few days that it took before. A lot of hours, a lot of man hours.
Can mention about how the core communicates, and we use 2 different protocols, both ISIS and BGP. ISIS is actually just for transmitting the loopbacks between the cores, and BGP is for the internet, the global IP routing. And to load balance all the traffic, since we have 2 10 gig uplinks, we have to load balance the traffic between these as best as we can. And for this we use something called GLBP. It's a proprietary protocol from Cisco. And what we do is we create VLAN interfaces, one on each core router, and use GLBP on both. And what happens is when traffic comes from the participants, it's actually load balance between both routers, and that's how we actually get a great balance on both internet links.
Thank you for watching this clip, and I hope it's been informative. Some information about the DreamHack Network. We have a lot of more things to tell, and I hope to see the people here from Pack for DreamHack again. And if you would like to know more, you can go to pack4dreamhack.com. Thank you.